Version 1.11 introduces data quality as code. This feature allows you to decentralize where you manage data quality test logic, enabling tests to be performed outside the platform while reporting results back to the platform, providing a centralized view. There are a couple aspects to this feature that we'll illustrate. To set up the example, we have a Snowflake service already ingested. Inside that, I have a customer database, and then a collate shop schema, which is comprised of multiple tables. On the code side, we're using VS Code and Python-based transformation pipelines. The first pipeline is our test runner and will transform and load the data directly. The second will extract the data, transform it, validate it, and then load it. The difference here is that if any defined test case fails, it acts as a circuit breaker, preventing bad data from being loaded into the table. Let's look at that first transform function. What we're doing is taking data from our customer and orders tables, aggregating them, and loading the result into a customer lifetime value table. Looking back, we see that the customer lifetime value table exists already. If I look on the data quality side, we see that no data quality tests are defined. So let's jump back into VS Code and look at that validate function. This function validates that the data we load into the final table meets certain defined conditions in our test runner function. As you can see, this just takes a few lines of code to run the validation. We just instantiate our runner object, reference the fully qualified name of the table we are validating against, and the test case we want to run. With that configured, we'll execute the data quality test. We see that our validation is completed and run as expected. One data quality test failed and one succeeded. This was the correct result for the scenario we established. This allowed us to directly capture the results of the transformation pipeline and then perform whatever tasks we are interested in. This information is also pushed back directly, and we can see it in the user interface. You see that the incident alert is showing up on that table. Remember, the failed quality test. Down here, we see those test case results that were pushed back. Now we click on it and explore what was happening and the reason for the failure. Then, in the Overview tab, we'll have additional information about what is passing or failing. So you see now how you're able to manage the data quality test logic outside of the platform, but it is reported and visible within the platform. This can then be stored in a version control library and provided to your data engineers as a data quality library that is executed as part of your pipeline, with results going right back to the platform. Back in VS Code, let's look at our second scenario, runtime validation. As mentioned earlier, this acts as a circuit breaker if data fails the data quality tests. In our code, we're extracting orders and product details. If we look, these are simple queries that return data frames. Looking at our transform product performance function, we're basically just merging data from orders and product details, performing some aggregations, and returning the results as a data frame. Then we have the validate and load steps, and that is where we come into play. Instead of defining a test runner this time, we're defining a data frame validator. This is the same logic as before. We're adding the test to our validator, which in turn will call the run method, which will execute the data quality test. We're passing two callback functions, one for success and one for failure. If it is successful, we will load it into the product performance table. If there is a failure, then we will roll back. Something to note is that the run method defined here will accept chunks of data, so if you're working on large data sets, you can simply chunk your way through them. Like with our previous example, we can write these results back to a specific table. You'll note that we have the product performance table here, but there are no data quality test results. Let's run our program and get some results. Looking at the run log, we have the expected validation error. Since one of the tests failed, we don't want to load this data back into our final table. Back in our UI, we can see the data quality test we ran in code is now visible. We can explore deeper and see that it failed because the minimum value is below 0, in this case, minus 521.12. We also see that an incident has been opened, and the incident icon appears at the top. In the Overview tab, we will also have information about which quality tests are passing and which are failing. With data quality as code, the landscape for centrally managing your data ecosystem has gotten even more inclusive. Data quality dimensionality has been introduced in version 1.11 as a column-level dimension test. To illustrate, we'll use Redshift and select the orders table. Now we navigate to the Data Observability tab, then select Data Quality and click to add a new test case. What you'll notice is that in addition to the table level and column level tests, we've added the dimension level test. This is how we create a column level test with a dimension, so we'll select that. Next, we'll pick a column from the table that we want to perform a test case on. We'll select Amount. Now we need to select a dimension that will allow us to create a test to be executed from a dimensional perspective. We select Status. We only need the one dimension for this test, but you can choose as many dimensions as you wish. For our test case, we want our values to be not null. And actually, let's make this gift card amount. We can also add a description, which is always a good idea, tags, and glossary terms. Let's go and create that test and then execute it. But first, let's create the same test as a column level test with no dimensionality, so we can see the difference. Select the gift card amount and then the not null test, and then we'll create the test. We can already see a difference in the test cases. The one with the dimension quality has an icon here indicating that one dimension is associated with that specific data quality test. Our regular test does not have that indicator. Let's go ahead and run that pipeline now to run both tests. We can see that the test cases ran successfully, so let's now see what the difference between them is. We'll start with the regular one by clicking on it. You see our overall results. I see that 99 rows passed and 0 failed, meaning there are no null values in that table. So let's jump back to the data quality page and we'll explore our dimension test. We have the same information available as before, but I also have a new dimensionality tab. We click on that tab, and if there are more than one dimension, we would select that here. What you see is that we have a run state per status value. In this case, all the tests passed, but if there were failures, then the impact score would tell me which dimension is carrying most of the failures, which can provide insights into where the trouble might lie, providing an additional layer of granularity to really expose additional information. We can easily adjust the run history we're concerned with to look for patterns across a larger window. You can go even further with this. If you want to check the historical execution of a particular dimension, just click it to easily see the history of success or failure. In the past, to get this kind of flexibility, it required writing custom SQL code, which would likely be far more brittle and require more maintenance. Now, with data quality dimensionality, it just takes a few clicks. Come try it for yourself.